Okay, so let's now look at just some of the types of forces that we can find in molecules, and I'm not going to mention all of them, only those relevant in understanding the forces involved with alkanes. Okay, the first type of force is when we have ionic bonds. Now, you have to remember that in organic chemistry we are not working with ionic bonds. We're working with covalent bonds, but you need to understand ionic bonds and the forces that exist there in order to understand the type of forces we encounter in alkanes. In an ionic bond, you'll remember we have a positive ion and a negative ion. So we have a cation and an anion attracting one another, and these two form a molecule. Okay. They form a molecule, and in this molecule the one end is negative. The one end is negative, the other end is positive. Okay, which means we have two poles, a positive pole, okay, and a negative pole. This is called a dipole. A dipole, di referring to two-pole molecule. There's two poles in this molecule. When we have a dipole molecule, we have what is called dipole interactions. So dipole interactions. That just means we have a dipole molecule interacting with another dipole molecule, where the positive end of the one is being attracted by the negative end of the other one. And we looked at this, I did explain this, okay, and the negative end of the one is attracting the positive end of the other one. This is very strong intermolecular forces. Okay, this is very strong force. In other words, the correct word to use is an ion dipole force. Ion dipole force, they are the strongest forces that you can encounter, and the bigger difference there is between their electronegativity. Again, if you don't remember this, refer to the videos where we do talk about it. The bigger the difference between the electronegativity, the bigger that force is. And something like this is sodium chloride, that is table salt. We know table salt is a very hard substance, and therefore and that's indicative of the strength between the molecules. Okay, that's in an ionic bond, and it is this difference between the charge of particles, or where there is a positive charge and a negative charge, that causes particles to attract each other. Okay, that is what causes the attractive force. So even in covalent bonds, this is what we are looking for. Dipole, and it's called dipole moments. At a certain moment of time, the electrons gather at a certain point in covalent bonds. Okay, so the electrons aren't always at the same spot, and at sometimes those electrons can group together, making it more negative at a certain point and obviously more positive at another point. Now this is more prevalent in covalent bonds, okay, where this appears. So let me give you a simple illustration. So if I were to have 3 carbons bonded here, okay, 3 carbons, and we know that the hydrogens are bonded around it like this, okay. Now we don't necessarily have, because now we can see the electrons in essence are being shared. So they can be at any moment of time at various different places. But what happens is that at some moment in time we might encounter more electrons on this side, okay, and making this a more negatively charged, which means that side might be a bit more positively charged, which means at certain times in time, the particle itself, the molecule itself, has a charge at one end. This type of force, and we call this intermolecular forces, all of these is the internal force between molecules. Okay, this is called van der Waals forces. Van der Waals forces. In other words, van der Waals forces represent a force that exists due to a temporary unequal distribution of electrons. Okay, so that temporary unequal distribution of electrons causes a certain charge at a certain point, and that is called van der Waals forces. Now we get different types of van der Waals forces that have different varying strengths, and I'll explain more about that when we get to some of the other organic substances. But when it comes to alkanes, we are primarily working with this unequal distribution of electrons, and this and again, as I say, there's more than one type of van der Waals force. The one that is specifically involved here is called the London, can also be called London forces. Well, I'm sure there's a reason. I don't know what it is, why it's called London forces, but the unequal distribution of electrons at a certain moment of time, because there is a clunk of electrons at a certain point, that's called London forces. Now, one thing to note about these forces are they are weak forces. They are not strong forces. So we'll look at what effect does the chain length have on the strength of these weak London forces.